Got it. Right. So yeah, in our last class, we have seen what is voltage, current, and we have seen Ohm's law, right? Which is, yeah, and then we have seen Kirchhoff's current law and Kirchhoff's voltage law, and we, yeah, solved a few simple examples, right? So in this unit, we are going to see three other theorems, right? Superposition theorem, Thevenin's theorem, and Norton's theorem to solve simple electrical circuits, right? So yeah, before going deep into these theorems and solving examples, right, we'll see about potential dividers and current dividers, right? These two will be very useful when you are solving any kind of electrical circuits, right? First one is, let's see about potential dividers. Can you see the text? Yeah, can you read the potential dividers, right? Maybe the spelling is mistake. Okay, leave it. Right? So a potential divider is simply two resistors connected in series, right? And this is connected to a voltage source of V or battery of V, right? Let this be V, and this is R1 and R2, and this will be my output, right? Let me mark it as V out, right? So this is V, or I'll mark it as V in, right? And then I have two resistors connected in series, and then I have V out here. Right now, let's see how we can define V out in terms of R1, R2, and V in, right? Okay, for that, first we'll mark the current through the circuit as I, right? Current through the circuit as I. So the whole current will be, yeah, flowing through this loop, right? This is open circuited, so don't worry about this one. Current will not go through this one since there is no closed loop. The whole current will be flowing in this loop, right? So there is a V and two resistors connected in series. So I can write my current I as V in divided by these two are connected in series. So the resultant resistance, I can simply add them together, right? R1 plus R2, right? So my I will be V in divided by R1 plus R2. And then now what will be my V out? What will be my V out? Yeah, if I apply Ohm's law to this resistance, or if I apply Ohm's law across points A and B, right? A and B, the voltage across those 2 points is V out, right? So as per Ohm's law, V out equals to I into R2. Am I right? I into R2. Right, so I can say that I can substitute this one, right? So I can write it as R2 divided by R1 plus R2 times V in, right? So this will be my V out, right? So whenever you have to a potential divider, the voltage will be R1, sorry, R2 divided by R1 plus R2, the summation of those two resistors, right, into the input voltage, right? If you need to calculate the voltage across a single resistor, you can simply, if it is connected to a voltage source, you can simply, yes, that resistor divided by the summation of these two resistors into the whole total voltage applied across the combination of resistor, right? So this is called as a potential divider, and this will be very useful when you are solving simple electrical circuits. Now we'll see about current. Okay, here the current is not going to be divided, right? Since there is a single loop, right? There is a single loop, the current will not be divided. Okay, so the potential will be distributed among these two resistors. Right, now let's see about current divider. Right, current divider will be two parallelly connected resistors, something like this. Right, let this be R1, R2, and I have a current of I. Right, so let the current through R1 is I1 and current through R2 is I2. Right, let's see how we can define I1 and I2. Right, now, okay, take this point as A and B. Right, we'll apply Ohm's law across these 2 points. Right, if the voltage across A, B is V, right, then the voltage across R1 is V, and also the voltage across R2 is also V, right? The VAV will be equal or same for both R1 and R2, right? To calculate VAB or V, right? So let's mark it as VAB, right? I need the resultant resistance of these two, right? These two are connected in parallel, right? When R1 and R2 are connected in parallel, right? If I take the resultant resistance as R, then I can write it as 1 over R equals 1 over R1 plus 1 over R2, or simply 1 over R equals R1 R2 over R1 plus R2, R equals R1 R2 divided by R1 plus R2. We have seen this one in our last class. So when you have two parallel resistance, simply multiply them divided by summation of them will be the resultant resistance, right? So now R is this one and the current through that is I. Then VAB will be R1 R2 divided by R1 plus R2 times I. Right? This will be my VAB. Then now I am going to apply Ohm's law separately for these two resistors, I1 and R1. Right? So I can say that VAB equals R1 into I1. Am I right? So my I1 will be VAB divided by R1. Clear? So this is my VAB divided by R1 means R1 and this R1 will be getting cancelled. So I can write my I1 as R2 divided by R1 plus R2 times I. Similarly, if I apply the same Ohm's law across this resistor, VAB will be I2 into R2, right? When I am dividing it by R2, I can write my I2 as R1 divided by R1 plus R2 times I. Clear, right? So at voltage divider, you are simply, yeah, the same resistor divided by the summation of these two resistors into Vn. But when it comes to current divider, will be the opposite resistor, right? For I2, it will be R1 divided by R1 plus R2. For I1, it will be R2 divided by R1 plus R2, right? Now, for example, if R2 is greater, right? R2 is big, right? R2 is greater than R1. Then, right? if R2 is a higher resistance, consider it as 1 kilo ohm resistance, and this one has 100 ohm resistance, right? So I will have high current through low resistor. Am I right? I will have high current through low resistor. But here I will have higher voltage portion across the highest resistor. Clear, right? So remember this one. So this will be very useful for you to solve any simple electrical circuits to an electrical network, right? I would say. Right. Now we'll see a simple okay, right. I think I have an example here. Right, give me a second. Right, so we'll solve a simple circuit, right? First. Let this be 5 ohm, 10 ohm, 5 ohm, 5 ohm, and 10 voltages. Ohms, right? Right. So now the question is, you need to calculate the current through each branches, each resistance, right? So you can apply both Kirchhoff's current law and Kirchhoff's voltage law to solve this one, right? First we'll see this one and then we'll go deep into the other theorems, right? Okay. If the current is I, right? I'll mark the current as I, and then at this node the current is going to divide along these two branches. Am I right? So I can make it as I1 and I2. Of course this I1 will come through this resistance, and here I will have I1, and then I2 will be here, I2, and at this node these two will be again make I, and then the circuit will be completed. Clear? Right. Now the green is a bit dodgy. Okay, right. So at this point, if I apply Kirchhoff's current law, right, I can say that the incoming current is I1 and I have two outgoing current branches. So I can say that I equals I1 plus I2. Clear? I1 plus I2. Or simply what I can do directly is I can make it as I2 as I minus I1, right? That is my choice, right? I can make it as my choice, right? So before making into or before going into the further calculations, we can try to calculate the total current I, because this I, right? So again I have a resistor here, so I cannot calculate any other voltages, right? So I can simply calculate I, right? To calculate I need to simplify the whole resistor network, right? Look at here, this 5 ohm resistor and this 5 ohm resistor is connected in series. Am I right? These 5 ohm and 5 ohm are connected in series, and the resultant resistance will be 10, right? So I can remove this one and I can make it as 10. Again, these 10 and these 10 are connected in parallel, right? So 10 parallel 10 will be 10 into 10 divided by 25, right? When they are equal resistance, the resultant resistance will be half, right? So 10 and 10 means R will be 10.10 divided by 10 plus 10, right? So it will be 100 divided by 20, which is equal to 5, right? So this will be the whole resistor network can be replaced by a single 5 ohm resistor. Again, that 5 ohm resistor and this 5 ohm resistor are connected in series, right? So the total resultant resistance will be 10 ohm, and I can say that I equals 10, right, divided by 10, right? 10 voltages divided by 10 ohms, right? Because V equals I into R, I equals V by R, right? That's how I have written here, right? So I can say that my I equals 1 ampere, right? So this will be 1 ampere. Again, look at here. I can say these two as current dividers. Am I right? So this is 10 ohm resistor, another 10 ohm resistor, and I is going 10 ohm, 10 ohm. So simply I can calculate my I1 as 10, 10, right? So it will be equal. So 10 divided by 10 plus 10 into I, which is 1 ampere, right, will be 10 divided by 20, half, 0.5 amperes. If this is 1 ampere, this is 0.1 ampere, automatically this will also be 0.5 amperes, right? So here you are applying both Ohm's law, Kirchhoff's current law, current division, voltage division, and all those things, right? Okay, now we'll see how we can solve simple circuits using loop analysis, right? Or using your Kirchhoff's voltage law and Kirchhoff's current law, right? Now I'll draw and I'll show you another example, right? So, right, I have a battery and a resistor here. Right. So let this be 2 ohms, and this is 4 ohms, and again this is 1 ohm, right? So this battery is 4 voltages, and this is 2 voltage. Clear, right? This is 4 and this is 2 voltage. Now we'll see how we can solve this one using Kirchhoff's current law and Kirchhoff's voltage law. Right. If I want to apply Kirchhoff's current law, I can apply the current law at these nodes. Right. If I want to apply Kirchhoff's voltage law, then I need to find loops. Right. So I can say that, or I can consider this as my loop 1. Right. So this is my loop 1. And this, right, again, I can make it as yeah, here I started from positive, right? Because the loop 1 means I am marking the current direction, right? Because always the current will be flowing from plus to minus, right? Again, at this point, we will make it as loop 2. Right? So consider the current through loop 1 is I1 and current through loop 2 is I2. Right? Current through loop 1 is I1 and current through loop 2 is I2. Now apply Kirchhoff's voltage law to write, okay, KVL to loop 1. Right? Apply Kirchhoff's voltage law to loop 1. right? So there is only one battery. Of course, the current is started from positive. So 4 equals, right? See here, the current I1 is going across 4 ohm and 2 ohm in the same direction, right? So I could say I1 into this 4 plus 2, right? And see here, in your 4 ohm resistance, you have I1 in this direction. Of course, you have I2 in the same direction as well, right? So this one will be, or the current through the 4 ohm resistance will be I1 plus I2. Clear? If you mark the loop in the other direction, right? If the direction is in the other way around, then you need to consider the current through 4 ohm resistance as I1 minus I2. Here, I make it in a way that, right, the current is flowing from plus to minus, right? If you put it the other way around, the battery will be minus, but the current through the branch will be will also be minus, right? So it depends on you, right? So here we have I1, which is flowing through the 4 ohm resistor and this 2 ohm resistor. But in this 4 ohm resistor, I have an additional current of I2, right? So I could say plus I2 into 4. Right, now apply KVL to loop 2, right? Apply KVL to loop 2, which is this one, right? So here battery is plus, right? So the voltage is, the current is starting from the positive. So 2 equals, again here I2 is flowing through this 4 ohm resistor and 1 ohm resistor. So I could say that 4 plus 1, 5, right? I2 dot 5, and then addition to that, in addition to that, I have an I1 component in this 4 ohm resistance, which is 4 into I1, right? So I1 into 4. See here, I have two equations, right? And then two variables, right? Simultaneous equations. You can calculate I1, I2 by simply solving it, right? So I can rewrite the equations at 6I1 plus 4I2 equals 4, and 4I1 plus 5I2 equals 2, right? You can solve these two equations and you can get the current values of I1 and I2. Clear? I1 and I2 by solving this one. I'll leave it to you, right? You try solving this one by yourself and let me know the answers. Right, now tell me what is the current through the 2 ohm resistor now. If this is I1, of course, the current through 2 ohm resistor is only I1. Similarly, the current through 1 ohm resistor is only I2. But the current through 4 ohm resistor is I1 plus I2. Remember, when you are when the question is calculate the current through 4 ohm resistor, you have to say that yes, current through 4 ohm resistor will be, right, if the current through 4 ohm is marked as I, then I equals I1 plus I2. Clear? So you need to calculate I1 and I2, and then you need to add them together to give the final answer. Can you please solve this one? Tell me what is I1 and I2. If you have a calculator or something else, it's a simple simultaneous equation, right? Someone of you? Yeah, paper just solve and was it I1 equals 6 by 7 and I2 equals minus 2 by 7? Am I right? Yes, yes, yes. SP 071, you are right. Okay, right? So if I want to calculate I1 plus I2, what I have to do? I need to add these two together. So it will be 6 by 7 plus minus 2 by 7 will be 4 by 7 amperes. Right? Don't simplify this one, right? Using your calculators, right? You can use, you can give the answers in this form, in fractional form. I'll give you full marks, right? In your exam papers, right? Don't worry or don't think that you need to solve this one and put it in the decimal form, right? This is enough for me. I just want to know whether you can able to get these two equations from this one, right? You can draw the circuit, note the currents, and then you should be able to solve it, right? Okay. So what we have done is, this is just a simple loop analysis, right? This is called as loop analysis, right? I'll give you a practice questions to you, right? I'll give you a practice question, right? Now, let's see. Okay, we'll start with superposition theorem, right? Superposition theorem, right? Okay. What superposition theorem says is, see here, we have a we have a battery here and here as well, right? We have a forum. Can you see the slide? Can you see the video? Okay, right? So I have batteries here and here, right? We can solve the circuit using superposition theorem as well, right? A superposition theorem. Okay, I'll draw another circuit which is simple, right? Otherwise it will be difficult to consider this circuit, right? I'll make it simple for right. Okay. Oops. Then a resistor here. I have a resistor here. Right, so this will be 12 ohms, 12 ohms, and 6 ohms. Right, so 12, 12, 6, and this is 6 voltages. And this is 3 voltages. Right, this is 6 and this is 3. Now, the question to you is, right, calculate the current through this 12 ohm resistance I using superposition theorem, right? Of course, you can solve this circuit using nodal analysis, but you have asked a question by solving this question or by solving this one using superposition theorem, right? What superposition theorem says is you need to solve the circuit twice, right? First, you can solve it without this voltage source, right? So this will be short circuited, right? The voltage source will be short circuited. Now you have only one resistor, sorry, one battery. So you can simply solve this one, right? 12, 12 parallel. So 6, 6, 12. So you can simply calculate the current, right? Through this one. And also you need to solve again by hiding this one, right? By removing this one. Again, you will have another value for this one, right? What superposition theorem says is when you have two batteries, the current will be equal to the summation of the values when you are doing without one and without another, right? Can you understand? Right. So that is the simple words, right? So you can, if I calculate the current through this one without this voltage, let's consider the current through this one is I1, and without this one, let's consider the current through this one as I2. Then with these two batteries, the current I will be the summation of the currents I1 plus I2, right? Okay, I'll solve this one and show you, right? So first, we'll simplify the circuit without this 6-volt resistor, 6-volt battery, right? So we can remove this one, and I'll redraw the figure again, right? I don't want to hide it. I'll redraw the figure, right? So now I have a 3 ohm batteries, right? So this is short circuited, so I can have only that 12 ohm resistor. Am I right? This will be 12, 12 and 6. This is 3, right? Let mark the current through this one as I1, right? Now, how to calculate I1, right? We can calculate I, which is right. Now, 12, 12 parallel, so that will be 6. Am I right? When they are equal resistance, that will be half, right? 12 parallel 12, 6 and 6 will be 12. So I can say that my I equals total 12, 3, right? So V by R, 3 by 12 amperes. Or I can say that 0.25 amperes or 1/4 amperes, right? Okay, now that I is going to divide it among these two resistors, then what will be my I1? Right, my I1 will be, again, I have to apply current division across these two. Since these two are equal resistance, my I1 will be half of I. Am I right? Half of I, or I can say that 1/8 amperes. I1 is 1/8 amperes. Right, now we'll calculate I2 by keeping this battery alive and this battery short circuited. So I'll redraw the circuit, right? So I have 6 ohm resistor, 12 ohm resistor, and then this is 12, right? Remember here the battery, this one is plus and this is minus. Am I right? So, but we'll make the current. So since I'm going to have current through this way, and I'll mark the current direction, this one, let this be I2. Can you see this one? I think, is it too small? You can see, no? I1 and I2, right? I2. Again, 6 and 12 parallel, right? So this current, let's take it as I dash, right? If it is I'll take it as I dash. So my I dash equals 6 parallel 12, right? So 6 into 12, 6 into 12 divided by 6 plus 12, right? 6 plus 12, which is 18, right? So 3, 4, right? So 4 ohm resistance plus 12 ohm resistance. The total resistance will be 16 ohms, and this will be 6 voltages, right? So my I dash will be 6 voltage divided by 16 ohms ampere. Or I can say that I dash will be 3 by 8 amperes. Right now, what is my I1? Sorry, I2. I2 again will be divided by these two branches by applying Kirchhoff's current law, sorry, current division rule, right? So I2 will be if, right? So I2 through the current. So what I can say is, yes, the opposite resistance, 6 divided by 6 plus 12 into I, right? My I2 will be 6 divided by 6 plus 12 into I. So 6 divided by 18 times I, right? So 1/3, right? 1/3 into I will be 3 by 8, right? So I2 will be 1/8 amperes. Clear? 1/8 ampere. Right? So I2 will be 1/8 ampere, right? 1/8 amperes. Right. So what is the net current through the resistance, 12 ohm resistance? Yes, I1 will be 1/8 ampere, which is flowing from top to bottom. I2 will be 1/8 ampere, which is flowing from bottom to top. So what is the net current? What is the total current? What is I? Will be I1 plus I2, which is 0 amperes. Am I right? There will not be any current flowing through this 12 ohm resistor. Clear? So this is what superposition theorem says. Right? So I have an example uploaded in your Google Classroom, and yeah, I think a recording is there. So you can practice that question by yourself. Right? I think with this one, we can do we have time? No. Okay, I'll give you an example, right? You just try yourself and tell me the answer, right? You guys just take a piece of paper, pen and paper. I'll give you a question, right? Apply superposition theorem. Give me the answer quickly by applying, you have to send me I1, I2, and I, right? Okay. So I'll give you the circuit, right? So let this be, and 4 voltages, this is 4 ohms, 2 ohms, right? The same circuit I gave you before, right? 2 voltage. It's easy for us to, sorry, resistor here, which is 1 ohm, right? 2 ohm, 4 ohm, 1 ohm, 4 voltage, 2 voltage. Calculate the current I using superposition theorem, right? Yeah, you can try it yourself, right? You can try yourself and give me the answer, right? Of course, the same question, right? The same question we have done here, right? 2, 4, 6. So the answer will be same, but what I need is, I need I1, I2, right? And then finally, you can give me the final answer, right? You can get the final answer, right? Okay, try yourself. I'll give you 5 minutes. Try yourself and send me the answer, right? Because of course we know the final answer, but what I need is, I know what I want and I2. Okay, right. Sorry, yeah, I didn't realize that my mic is unmuted. Okay, so you can practice this question by yourself, right? And yeah, we can wind up the session. So by next week, we have two more theorems, right? The Norton's theorem and Thevenin's theorem. By those two, your first chapter in electronics is over, right? So your electricity is over. So you can practice some of the question. I will upload it in Google Classroom, and yeah, we'll do the tutorial once you come back to the university, right? That's what I am planning, because there is no use, right? We need to do the tutorial sessions.